Hi friends, welcome to Entry app. Guys, GATE exam is like the most prestigious exam in this entire country. It's not only important for your career, but it's important for building this nation also. It is through GATE exam that Indian government is going to get the officers they require in ONGC, BHEL, NTPC, NHPC, SJVN, HEL, Mahajan Limited, basically the PSUs who are building this nation. They are making roads for us, they are making inland waterways for us, water supply system, our defense systems. Then they are going to get, the government is going to get scientists from the same exam. If you are preparing for GATE, most probably you want to go into IITs for masters and PhD, where you will learn how to do research and you will become scientists and professors who are developing new technologies for us. In past few years, you have seen how much IITs, ISRO, DRDO, BARC, DST, CSIR, ADA, etc. have been contributing to developing new technologies, so that instead of importing from other countries, we can export them. Through GATE exam, we also get those people who can do research in management. So, fellowship program in management which you undertake in IIMs, that is through GATE exam, right. Then for you, through GATE exam, you can also go to foreign universities. And what happens is that generally in BTech, we are not ready for direct R&D jobs, but through GATE exam, you can directly get R&D jobs. However, after BTech, if you are applying yourself, or even if the companies are coming to your college, they will not offer you R&D job directly. Either they will take you in production, they will take you in quality, they will take you in maintenance, marketing and purchase, or at max engineering and projects, but never R&D, right, or design also, but never research. So, if you want a direct job after BTech in R&D, then you can go through GATE exam and apply for junior research fellowship. So, yes, GATE exam is giving us a lot of opportunities. Even in Army, Air Force, Navy, etc., when we apply and we show them that we have scored these many marks in GATE exam, you get additional score in SSB. Do you know that? When you fill the form for technical regiments, there it is written, have you cleared GATE exam? If yes, what was your score? So, that is an additional marks to you. So, GATE exam has lot of advantages. Anyways, in this short video, we are going to discuss the syllabus. And it is not like that we will dive very deep into the syllabus. We will only discuss that these are some of the topics which you have to focus upon, and overall this is your syllabus. And obviously, when you are going to start a subject, then you will have much more detail of that subject, chapter wise detail of that subject. Okay. So, guys, first of all, if you are a very fresh student and you think that your concepts are not up to the mark, in that case you should always follow an order of the subjects. You will say, sir, what order of subjects? By order of subject, I mean which subject to read first and which subject to read last. Say for example, when we talk of maths, maths is extremely important in mechanical engineering. You know why? Because maths is the language of science. It is math with help of which you write down a concept on the formula, you write down the concept in form of formula on paper and pen, isn't it? Isn't it? You write a concept or a law in terms of formula through paper and pen. That is maths only. Maths is the language. So, understanding this language, knowing this language is very important. Then only we will be able to understand what the books are trying to say, what the teachers are trying to say, isn't it? Suppose I stand in front of a German guy and he doesn't know my language, or I do not know my language, but that guy is very much knowledgeable. I will not be able to learn even a single point from him. So, understanding the language is very important, and that is maths. So, first you should always go for maths. Moreover, out of 100 marks of GATE exam, maths is going to give you 15 marks, around 15 marks, right, 13 to 15 marks. And if you know maths, the basics of maths are going to be helpful to you in the derivations of strength of materials. The basic of maths are going to be helpful for you in the derivations of theory of machines, especially vibration chapter. The basics of math will help you a lot in the chapter of fluid mechanics, because fluid mechanics is maths only. It is like maths only. And then the same maths will help you in derivation of heat transfer also. Moreover, maths is going to help you a lot in a subject called as industrial engineering. For all these subjects, if you are good in maths, especially differential equations. What? Differential equations. So, for some theory of machine, fluid mechanics, heat transfer, you need differential equations and calculus. You remember calculus, maxima, minima, graph, then differential equations and solving differential equations. So, those two chapters are required over here. But for industrial engineering, you need probability and statistics also. So, if you know maths now, not only you will get these 15 marks, but you will get these remaining marks also. That is why maths is very important. Now, there is the subject of engineering mechanics also. So, engineering mechanics simply means how things move. When you apply force, how things move, right? So, concepts of engineering mechanics are important for strength of material. Concepts of engineering mechanics are important for theory of machines, and the concepts of engineering of mechanics are important for fluid mechanics also. So, engineering mechanics is the prerequisite for these three subjects. Okay. However, the weightage of engineering mechanics is less. On an average, if you take the average of last 20-25 years, it is only 4 marks. So, it is a very important prerequisite, because it will make your life easy in these three subjects. That is why it is very important. So, even though its weightage is less, but I would always suggest that before doing these subjects, you must go for engineering mechanics. Now, there is one particular subject, that is manufacturing, and manufacturing is like for GATE exam now, manufacturing does not have too much maths or too much concept of mechanics. In actual, definitely manufacturing requires maths, manufacturing requires thermodynamics also, manufacturing requires a little bit of fluid mechanics and heat transfer also, manufacturing requires a little bit of engineering mechanics also, in fact a lot of engineering mechanics and SOM also. But our syllabus of manufacturing now, it is not much based on these subjects. So, you can study it just after maths also. And why you can do that? Because manufacturing is a big subject and it has a lot of knowledge based points in it, not concepts, knowledge based points. What is the temperature of this? What is this temperature? What is this material? Okay, like this. So, such kind of subjects you have to revise again and again, then only your memory of this subject will be sharp. So, if you do the subject before the other subjects, you will have a lot of time to revise this subject. You can revise the subject again and again, and you will definitely become very strong in the subject. And why it is important to be very strong in the subject? Because it will hold a weightage of 17 marks. That is why it is very important. So, you can do one thing, you can prepare maths first, then you can start preparing manufacturing. Okay? And after your maths and manufacturing are over, then you can look for remaining subjects also. Sir, is there any subject which is pending? Yes, a very big subject is pending, that is thermodynamics, and thermodynamics will hold a weightage of 9 to 11 marks, most probably 10 marks. So, it is a big subject without any prerequisites. So, whenever you are starting preparation of GATE exam now, it is always important to cover these subjects first, because these subjects they do not have prerequisites. These three subjects they do not have prerequisites. In fact, they are the prerequisites of other subject, and manufacturing has a lot of weightage. So, it is always suggested to go for these subjects first. Then what about SOM, sir? How much weightage? 6 to 8 marks. Sir, how much weightage Tom? 7 to 9 marks. Sir, how much weightage FM? 7 to 9 marks. How much weightage heat transfer? 4 to 5 marks. And how much weightage industrial engineering? 4 to 5 marks. And yes, there is general aptitude also, right? So general aptitude itself is 15 marks. I think if you will take the sum, it will be somewhere around 85 now. So 10 plus 4, 14, 14 plus 15, 29, 29 plus 17, 46, 46 plus 7, how much is that? 46 plus 7 is 53, 53 plus 8, 61, 61 plus 8, 69, 69 plus 4, how much? 73, and 69 plus 4, 73, and this contributes to 80. So basically 1 marks here and there. Actually the weightage of a subject is not fixed, it can go up and down, okay. So near about they are going to give you how many marks? Or 85 marks, 15 marks will be aptitude. Now let us do one thing, let us discuss the syllabus one by one. What is the syllabus of thermodynamics, fluid mechanics, heat transfer, maths, and then engineering mechanics, then strength of materials, theory of machines, machine design, etc. You might say, sir, why you have not written the topics of first 4 subjects? Bhaiya, I am the best expert of these subjects. So I don't need to write the topic of these subjects. I can tell you directly, okay, that's why. So guys, thermodynamics. So this subject, thermo plus dynamics, means thermo means heat and dynamics means the effect of heat. Dynamics means effect, change, variation. So variation due to heat. So in actual, a little bit of talking of thermodynamics was going on from 2000 years only. But the subject came into picture when steam engine came into picture. When we realized that yes, heat can be converted into work. That is when the subject started. And initially the aim was to understand how we can convert heat into work and what are the effects of work. But later on, when we started designing the steam engine, we started developing the concepts of thermodynamics. That is when we realized, oh, the concepts which are applicable over here are actually applicable throughout the universe for any kind of phenomena. The concepts which are applicable during boiling of water and moving the piston are actually applicable whether a chemical reaction is going on, whether the stock market is falling down, whether the universe is expanding, whether the sun is giving us heat, whether a plant is growing, whether someone is dying, anywhere the laws of thermodynamics are applicable. So the definition of thermodynamics changed, and then we realized that thermodynamics is simply the science of energy transfer. If you transfer energy to a substance, how the properties of the substance will change, okay. So in thermodynamics, the chapters are, the very first chapter is the introduction only. In the chapter you will learn what thermodynamics is all about, and you will talk about like important terms. Some important terms like what is a state, what is a property, what is a process, what is a cycle, what is concept of continuum, then what is temperature. So these things you will talk about. And in introduction chapter, introduction and temperature chapter, you will also write down the zeroth law. You will also write down the zeroth law. Now some people, some teachers, they teach introduction and temperature separately. I generally teach it in a combined way, okay. But it depends from whom you are learning the subject. Then after learning the basic terms, what you will do? You will talk about work and heat transfer. You will talk about work and heat transfer. You will try to analyze if a system is losing or gaining energy in form of heat and work, then how the properties of the system, pressure, temperature and volume are going to change. So we will learn like different heat and work transfer processes will be there. Some process you will call isobaric, some you will call isothermal, some you will call adiabatic. So what will happen? Let us suppose we are heating a gas, but we are maintaining the pressure of gas as constant. So this will become isobaric process. Iso means constant, bar means pressure, constant pressure process. So you will learn that when we are heating the gas, then how the graph will look like. So something like this you will try to learn over here. And once you are aware of this work transfer and heat transfer, then you will learn first law of thermodynamics. First law of thermodynamics simply says energy can neither be created nor it can be destroyed, only it can be converted from kinetic energy to potential energy, or it can be given from one body to other body like sun to earth. However, it can neither be created nor it can be destroyed. So you will learn how to apply thermodynamics to various phenomena going on around us. Maybe combustion is going on in the engine. So how to apply this law over there? So first law of thermodynamics will be applied for two types of system. One is closed system and other one is open system. So you don't worry, you will learn what is a closed system, what is a closed system and what is a open system. You will learn it over there. So don't worry at all. Okay. Now first law of thermodynamics says that when a process happens, the energy is conserved. Someone may lose energy, but someone else will gain that energy. Okay, someone may lose energy, but someone else will gain that energy. So thermodynamics tells you energy conservation. Now suppose there is a rod. One side of the rod is hot, other side of the rod is cold. So hotter side will lose energy and cold side will gain that energy, and ultimately the temperature of rod will become uniform. So energy conservation principle only says one side is losing heat, the other side is gaining heat, but no energy is destroyed or additional energy is created. Hai na? Now suppose there is a rod. Maybe the rod is initially at uniform temperature. What if one part the temperature starts rising up and other part the temperature starts going down by itself? Can it happen by itself? No. If I have a rod, one side of the rod is hot, other side of the rod is cold, definitely they will exchange heat and ultimately the temperature will become same. But is it possible that initially the temperature is same and by itself one side the temperature starts going down and other side the temperature goes up? Now first law of thermodynamics says if one side is losing heat, temperature is going down, other side will gain that heat and temperature will go up. First law of thermodynamics only says this. But first law of thermodynamics does not say that this is not possible. It cannot happen that the temperature of this rod, which is initially same everywhere, it cannot happen that temperature of one side starts rising up by itself and other starts falling down by itself. This cannot happen. Similarly, if I will drop an object, the object will always go down. It will never go up against gravity by itself. So why the other process does not happen? Why the process happens in this particular way only? Why the process happens in this particular direction only? This is called as second law of thermodynamics. So what you will do after understanding first law of thermodynamics, you will talk about second law of thermodynamics. Second law of thermodynamics. Now guys, the concepts of thermodynamics are used for designing the working conditions of IC engine, working conditions of power plant, working conditions of air conditioner and refrigerator. Okay, the concepts of thermodynamics are used in these devices. So when you are learning the chapter of first law and second law, actually you will keep on practicing certain questions of IC engine, of refrigerator, etc. So you will see those devices again and again in these two chapters. Okay. Then once second law is over, you will talk about a very important property which we have not learned in the introduction chapter. That property is called as entropy. That property is called as entropy. Okay. Now how does entropy come into picture? Actually, when you apply first law for a closed system, so and then you apply first law for an open system, hai na? Similarly, you will do one thing, you will apply first law for a process and for a cycle also. Similarly, second law applied for a process and second law applied for a cycle. So, when the second law is applied for a process now, this property will come into picture that the substance has an additional property called as entropy. Every substance has a property called as entropy, and during any process, when the bulb is giving me light, when I am speaking to you, when you are watching the lecture, the entropy of the universe is increasing. So, we will talk about entropy principle and we will see how the entropy principle is applicable to the devices, power plants, IC engine, refrigerators, etc. Now, after this we will also talk of the concept of exergy, that how much out of the available energy, how much energy can be converted into useful form, and then the topic of some thermodynamic relations will come into picture like Maxwell equation, Joule-Thomson effect, okay, thermodynamic relations. We will also talk about, and guys, one thing I forgot, here we will also talk about pure substances. And draw different charts, pure substances and gases, and draw different charts for them. If you are heating them, what will be the pressure temperature chart, what will be the pressure volume chart, enthalpy entropy chart, enthalpy temperature chart, pressure enthalpy chart. Okay, so such kind of graphs we are going to discuss. Now, once this is over, then in thermodynamics you have to do some additional chapters. This is actually called as basic thermodynamics. So, what you have to do? You have to apply these concepts to power plants. So, that chapter will become Rankine cycle. Which cycle? Rankine cycle. So, you will see the thermodynamic cycle on which a steam power plant is based. In Rankine cycle, you will have some modifications also, like regeneration and intercooling. So, we are going to see the thermodynamic cycle of power plant, like what must be the boiling temperature in a boiler, what must be the condensation temperature in a condenser, how much power the turbine will produce, how much power will be required by the pump. So, what is the efficiency of a steam power plant, what will happen if we do regeneration in the cycle, what will happen if we do intercooling in the cycle. So, that you are going to talk about. Now, similarly, like you have talked about steam power plant, we will also talk about IC engine cycles. Basically, during the combustion process, how the pressure and temperature varies in the combustion chamber. So, IC engine cycles. So, there will be an Otto cycle related to petrol engines, diesel cycle related to diesel engines, similarly Brayton cycle related to gas turbines. Okay. So, a lot of cycles will be there. And actually, instead of writing here IC engine cycles, better we write down air standard cycles. What cycles? Air standard cycles. Okay. Air standard cycles. And the last chapter will be related to refrigeration and air conditioning. So, this is your subject of thermodynamics, and these are the important chapters that you have to do. Now, you will ask me, sir, what are the important chapters? Frankly speaking, every chapter is important. If you really want to become an engineer, then all these chapters are important. But still, from exam point of view, if you are asking, then definitely air standard cycles, Rankine cycles, refrigeration, air conditioning, then you have entropy, properties of pure substances, these are the most important chapters. Then sometimes from second law of thermodynamics, first law of thermodynamics, work and heat transfer also questions come. But yes, these chapters are, these star mark chapters are the most commonly asked questions in the exam. In fact, from refrigeration and air conditioning, every time 3 marks question might be there, 2 to 3 marks question might be there. Every time a 2 marks question from air standard cycle, and almost every time 2 or 3 marks from pure substances. So, it is like this, these chapters are the most important. Now, let us move ahead. So, I am not going very deep, I am just giving you a hint of the chapters. Now, when we are talking of fluid mechanics, so in fluid mechanics, first of all, definitely there will be the introduction of the subject. What the subject is all about. So, fluid mechanics. Mechanics means understanding the motion deformation of a substance. When you apply force, how the substance is going to move, how the substance is going to deform. So, if the substance is fluid, then fluid mechanics. Okay. So, first of all, you introduce yourselves. What is the objective of the subject? What are the applications of the subject? And you talk about properties, some important properties which will be helpful in understanding the motion deformation of the fluid. What are those properties? Density, bulk modulus, then viscosity, a very important property. When you are learning viscosity, there is an effect of viscosity called as boundary layer. Based on viscosity, we can classify the fluids. So, toothpaste is a Bingham fluid, water is Newtonian, but the liquid that we use in bulletproof jacket, that is dilatant. Quicksand is a dilatant. English people, they run on a liquid, that is dilatant. But shampoos, cosmetic creams, conditioners, they are pseudoplastics. So, that you will learn over there. Other important property from exam point of view, that is surface tension and vapor pressure, saturation pressure. Then after properties, you will move on to the first set of problems, that is fluids at rest. So, chapter name will be called as fluid statics. So, in fluid statics, you will see what is pressure, what are the units of pressure. Pressure is a scalar term, even though it is a stress. How to find out the pressure at a point, how to measure the pressure at a point, how to find out the pressure at any elevation in the atmosphere, because that will help us understand the lift force on the aeroplane, drag force on the aeroplane, distribution of pollution in atmosphere, filtering of thermal radiation. So, the basic calculation that you do in fluid mechanics has importance in other subjects. Then after measuring the pressure at any elevation in atmosphere, you will see what is gauge pressure, what is vacuum pressure, why in fluid mechanics we take gauge pressure for all calculations. Then you will see pressure measurement by manometers. So many type of manometers are there, which manometer is good where. Then how to find out the force on the surface of a dam. This will be called as hydrostatic force on submerged surface. There is a gate in the dam, the water is trying to open the gate. So, what should be the force in the stopping mechanism? And then we will see how to make the ship float and make it stable. What is the layout of the submarine, why the battery boxes and engine are in the lower compartment. This will become your fluid statics chapter, very important. Now, in all these examples, the fluid is at rest. So, what we will do? We will talk about fluids in motion. So, we will do one thing, we will divide the moving fluids into 3 chapters. First one will be fluid kinematics, then you will have fluid dynamics, and then you will have boundary layer theorem. So, actually what happens is, in case of moving fluids, so air is moving around the car, air is moving around the fan. So, how much force the air is applying on the car? To understand that, you must have the velocity vector, because from velocity vector you can find out a lot of information. From velocity of fluid you can find out a lot of information. So, from velocity of fluid we will find out what is the acceleration in the flow, what is the mean flow rate, what is the mean flow velocity, what type of flow it is, steady, unsteady, uniform, non-uniform, 1D, 2D, 3D. So, that chapter will become kinematics, and from the velocity we will find out pressure, that will become dynamics. Now, from velocity we can find out friction also, but here in this chapter now we will consider the fluid to be ideal, frictionless. So, friction we will talk about in the next chapter, that is boundary layer. So, here you can find out the friction also because of moving fluids. Now, once you understand how to calculate pressure and friction in moving fluid, you will do the application of the subject, you will do the application of these 3 chapters, that is flow through pipes. So, in your bathroom, in your kitchen, in your building, in your AC, refrigerator, in your cars, there is in your human body, there is a network of pipe. So, how much pressure the heart must develop so that the blood circulates very easily throughout the body and distributes the oxygen. So, that kind of calculation comes from this chapter, flow through pipes. Now, there are so many important fluid machines around us, like turbines which give us electricity, like pumps which raise the water to the top of building. So, we will also see them hydraulic machines. Hydraulic machines, and yes, there is one more chapter, that is dimensional analysis. So, you will learn the beauty of this chapter in your subject, dimensional analysis. It is an extremely beautiful and extremely important chapter. I will tell you about this there only. Sir, what are the most important chapters from exam point of view? Definitely dynamics, kinematics are very, very important, because every year question will come from them. And yes, flow through pipes is also important. Hydraulic machines, frankly speaking, questions come, but not such heavy questions. Simple questions only come from hydraulic machines. And yes, statics and dimensional analysis is also important. Okay. So, hydraulic machines and boundary layer, you can consider them at the same level. Actually, from hydraulic machines, not very heavy question comes. Questions come, but simple questions come. You can imagine in last 35 years, 36 years, more than that, only 45 questions have come. So, just imagine yourself, okay, what is the importance of this chapter in GATE. Though the chapter is extremely important in real life, but in GATE, its weightage is a little less. Anyways, heat transfer, next subject. So, in heat transfer, there will be 5 chapters. First one is the introduction. What is heat? What is heat? What is the objective of the subject? What are the various mechanisms through which heat transfer happens? So, you will say when we are talking of the sun, a lot of heat is produced in the core of the sun, but that heat reaches the surface of the sun by convection. So, there will be a chapter of convection. Mode of heat transfer is convection. Once the heat reaches the surface of the sun, it is received at earth by thermal radiation. And once that heat reaches the outer surface of the wall, how that heat is coming inside? By conduction. So, we will have dedicated chapters to each mode of heat transfer, and the last chapter will be an application called as heat exchanger. So, these are the 5 chapters. Maximum number of questions, and maximum number of questions. Okay, it's like this. Now, in conduction, so you will learn what is conduction, what is the equation used to solve conduction, what is the property associated with conduction, which you call as thermal diffusivity and thermal conductivity, and how to solve conduction in various scenarios. Like this wall is a planar body, how heat is going out by conduction through the planar body. The pipe is a cylindrical body, inside I have hot gas, how that hot gas is losing heat through cylindrical body, okay, like this. The thermocouple junction, that is a spherical bead. So, when the hot air passes by, how the temperature of the spherical bead will change by conduction. So, those things you are going to learn over here. Then the the energy that I am receiving from the bulb or from the sun, what is the frequency and wavelength of the waves? Okay. Now, what is a black body? How much energy is emitted by the black body? So, if we say this bulb is a black body, then out of black body, how much energy is falling on my surface? How much energy the sun and earth are exchanging? So, such kind of calculations we will do over here. And yes, heat convection is extremely complicated. When we are boiling water, water is rising up, how the heat is propagating. So, that we will learn over here. Convection is so important that the weather at your place is a result of convection. The cloth that you are wearing and food that you are eating is based on the convection in your region, in your state. Okay. Anyways, heat exchanger. Your laptop has a heat exchanger. Your AC has heat exchangers, refrigerator has heat exchangers, steam power plants have heat exchangers, IC engine has heat exchangers, they are everywhere. So, we will talk about them. Okay. So, this is your heat transfer. Next, mathematics. Frankly speaking, if you are when we are talking of maths, there are two possibilities of starting maths. Either you start it with linear algebra or you start it with calculus. I always suggest, or you can also do probability and statistics first. You can do calculus, you can also do probability and statistics first, and if you have a little idea of derivatives and integration, you can also start with differential equations. So, just hold on guys, let me write down all the units. So, these are units and these units have internal chapters. So, linear algebra, calculus, differential equations, then probability and statistics, then complex numbers, and in the last numerical methods. So, you can say like this: Laplace transforms and numerical methods. So, it is like on an average every GATE exam, every GATE paper, 3 marks from here, 3 marks from here, 5 marks from here, 3 marks from here, 3 marks from here, that is like average, fixed. So, a single chapter is definitely giving you 3 marks, it is like this. However, some ups and downs are always there. So, entire maths is important for you, but yes, suppose if you are late in preparation, you do not have much time, then you can ignore these 2 chapters for now, because it might be possible that you are getting only 1 marks question from numerical methods, or maybe 1 marks question from Laplace transform, or maybe no question from Laplace transform. This can happen, okay. But these 2 chapters are very small, so even if you are spending 1 day on these 2 chapters, you can do it. Anyways, so when you are starting maths, either you can start with linear algebra, you can start with calculus also, you can start with probability and statistics also, whatever you like. But I always suggest students to start with linear algebra, maybe because I teach robotics and CAD/CAM, so linear algebra is a part of that. But then I am much more deep into fluid mechanics and heat transfer, which is totally based on calculus and differential equations. So, frankly speaking, I do not know why, but I always suggest students to start with linear algebra. Maybe it is a little bit easy and looks more like maths, maybe that is why. So, when you are talking of linear algebra, what is a matrix? What are different types of matrices? How to write a matrix? How to write the definition of matrix in form of a formula? So, while solving them, while adding them, subtracting them, multiplying them, you can write short equations. So, yes, we are going to add matrices, we are going to subtract matrices, and we are going to multiply matrices. Once you understand what is a matrix, you are going to use matrix to solve linear equations, and for that there are various methods like Gauss elimination method. You will also talk about vector spaces, linear transformations, and you will talk about vector calculus also. In this chapter, the most important topic is eigenvalue and eigenvector problem, because definitely it is like if there are 10 sets of matrices, you will find eigenvalue problem in 9 sets. So, that is the most important topic of this chapter, linear algebra. Calculus, differential equation, everyone knows calculus means limits. Y is a function of x. So, if the value of x is approaching 0, then the numerical value of y will approach what? So, that is limits. What is a derivative? What is an integral? What is maxima minima of a function? How to find out the area of a surface? How to find out the volume of a body? So, those things you are going to learn over here. So, basically you will learn the meaning of derivatives and integration, and then we will apply this understanding over here to solve differential equation. Right now my body is losing heat by convection, that is explained by a differential equation. If there is a spring mass system, the spring is moving up and down, the floating ship in water is moving up and down because of waves, that is explained by a differential equation. What will be the pressure in air at this particular point, that is explained by differential equation. So what are the various types of differential equation, how to solve those differential equations, that you will learn over here. This time, who will win the World Cup? Probability. And analyzing a lot of previous data to predict the future. So that is probability and statistics. The world runs on probability and statistics, right? Very, very important topic. Yes, complex number will come, Laplace transform will be there, how to solve complicated differential equation by converting them into simple equations, and numerical methods, again an alternative to solve differential equations, and root kind of problems, finding root kind of problems. So your softwares, so which give you simulations like Abacus, ANSYS, etc. What they do? They use numerical methods to solve complicated differential equations. So you will learn about numerical methods also. Anyways, let's move on to the other subjects because I don't want to bore you much. So let me go through the subjects of the syllabus of other subjects quickly. Engineering mechanics everyone understands, right? So if the body is in equilibrium, what are all the forces acting on the body? If the body is moving, we know the forces, what will be the acceleration of the body, right? So first you learn how to draw free body diagram. Then you learn between two solid bodies what is the friction and what are the applications of friction. Then you learn this, I am inside a structure, this building is a structure. So how to find out the forces on various members of the structure. Okay, so I am sitting on a chair, on this steel chair, so there are so many rods on the chair, how to find out the force on every rod of the chair, right? So that you learn over here. There are some other topics also which will be helpful in your remaining subjects. Then strength of materials. So in the very first chapter you will learn that when we apply force on an object, the object will deform, and when the object will deform, there will be an internal stress in the body. So what is stress? How to write deformation in terms of strain? What are different types of stresses? What are different type of strains? What are the different properties which relate stress and strain? That is what you learn in the first chapter. Then in second chapter you learn that if on one plane in the body this is the stress, on the vertical plane of the body this is the stress, then what is the stress on the inclined plane? That you learn in the second chapter, more stress circle part. Then what you do? You take a beam, on the beam there is so much load, so what will be the shear force and bending moment diagram of the beam? What will be the bending stress in the beam? What will be the shearing stress in the beam? And what will be the deflection in the beam? Very, very, very important topic of strength of materials, because you can definitely expect questions from these. Then there is a shaft, we are rotating the shaft and transmitting torque. So how much is the twist in the shaft? How much is the stress in the shaft? There is a container for storing gas at very high pressure. How much is the stress and strain in that container? Deformation in that container. There is a column of the building. How much deformation is there in the column? And then last, energy methods for solving these problems. So when you are talking of this subject, actually thin shells, columns, this and this, these are the most important topics, and you will definitely expect question from at least SFD BMD, slope and deflection. You can definitely expect question from these. And this box now, if you know calculus, if you know how to make graphs, then this box will become very easy for you. SFD BMD, slope and deflection will become very easy for you. So your calculus must be strong if you want to be strong, if you want to be very fast in these chapters. Okay. Then one of the favorite subjects of everyone. So I'll tell you, in 1970s they found out a treasure near a island called as Antikythera in Greece. In the treasure a black box was found out which was highly rusted. After few years when we did X-ray, we found out that there is a very, very complicated combination of gears in that box. And carbon dating done. So carbon dating says the box is 2500 years old or even more. Now like you have gears in your watch now or gears in a toy car, I hope you understand what gears are. Through that combination of gears which we call as gear trains, they could predict the position of every planet and star in the sky. The calculations that we do by computers, and computers take a lot of days to give that calculation they were doing with help of gear trains. So, this is the importance of this particular subject. So, we will learn how to convert one type of motion into other type of motion, like in IC engine, the reciprocating piston you convert into rotation of the shaft of the wheels. So, how to convert one type of motion into other type of motion? So, reciprocating of the piston is converted into the rotation of the shaft, that will become a mechanism. So, what are the different types of mechanisms? This is what you will learn over here. Now, the shaft is moving with this velocity. With how much velocity the piston is moving with this velocity. With how much velocity the shaft will rotate? Velocity analysis chapter. If this is the acceleration of the piston, what is the acceleration of the shaft? If this is the force on the piston, what is the torque on the shaft? So, that analysis will come over here. Then yes, you will talk about gears, gear trains, flywheels, you will talk about vibration, a very important topic. Every year and many times 4 marks question comes from vibration, a very important topic. So, this is a very interesting subject, theory of machines, and these are the chapters of theory of machines. Okay. Anyways, here we have machine design. So, a good understanding of machine design comes when your strength of materials and theory of machines is good, because shafts and gears which you are going to design over here, shafts you will learn in strength of materials, gears you will learn in theory of machines, okay, and brakes and clutches you will learn in engineering mechanics. So, if you have done those 3 subjects in a good way, then this subject will become very easy. So, we simply want to design a riveted joint, welded joint, we want to design a a gear. So, all those things will come over here. You can press the pause button, take a photo, but these are going to be your topics or your chapters. Then, so we use so many materials. So, what are the fundamental of those materials? In steel, what is the combination of the steel and in what lattice the iron atoms are arranged? If we are going to heat iron, how the temperature of iron is going to change and how the phase change of iron will happen. If we cool down hot iron, what will happen? If we cool down hot iron suddenly or slowly, what is going to be the difference? So, all those things you learn in material science. Once you understand what are the properties of materials, hardness and red hot hardness, etc. Okay, I am not an expert of this subject. Okay, so please don't mind. Once you understand the properties of the material, you learn how to manufacture things from different materials, right? So, you talk about casting. So, what is casting process? What are the important terms in a casting mold? Okay, what are the various types of casting? If you want to manufacture this, what should be the type of casting implemented? What factors are going to affect casting, that you learn over here. Every year 2 marks, 1 or 2 marks, most probably 1 mark question comes from casting. Not a sometimes a numerical, like numerical on solidification time of casting. So, what is casting? You take an ice tray, pour some water which is liquid, the liquid will cool down and make solid ice. This is casting. So, solidification time question comes many times. And then joining processes. So, welding is a joining process. So, what are the various types of welding processes? Someone is doing underwater welding, what should be the process used? In automobile industry, we work with steel parts, we work with aluminum parts. So, when we are joining the parts together, what should be the type of welding used? What is aluminum thermite welding? Why it is used by people in the railways? So, all those things you are going to learn over here. What is soldering? What is brazing? That you are going to learn over here in joining process. What is extrusion? What is rolling? Okay. What is forming, what is forging, that you will learn over here. Now, everyone is aware of lathe machine, and I know that you have seen lathe machine in your college also. So what are the various operations on lathe machine and what is the dynamics of lathe machine, how the cutting of material happens in the lathe machine, that we talk about in the third chapter. So I have a bearing. I have a bearing which has a diameter of 10 centimeter, but I made a shaft of 10.1 centimeter. I am not aware that I have made a shaft of 10.1 centimeter and I am trying to push the shaft inside the bearing. So the shaft will not go inside the bearing and bearing surface will also get damaged. So it is very important to do measurement, metrology, and nowadays we are using computers for aiding our manufacturing process. So computer integrated manufacturing, definitely 3 marks from here, definitely 3 marks from here, definitely 3 marks from here, and 2 marks here definite, 2 marks here definite. It's like this. So 3, 3, 3, 2 plus 2, that is already how much? 13 remaining. Okay. So very important subject, very important subject, heavy weighted subject. Now when I was in the company, so once what happened, so every day we were giving 1000 parts to Maruti. When I was working in Manatee Marelli, every day we were giving 1000 air intake manifolds to Maruti. Once our machine broke down, and that broke down was heavy. It took around 7 days to rectify the problem, to make the machine run again. But we could survive because we had an inventory of 7 days. So how do you make inventory? How do you make inventory, and what are the various types of inventory that you do? You learn over here. I was in a service based company. Maruti needs something, we will develop an assembly line, we will manufacture it and supply to them. So I was in a service based company. But you are going to make a startup, you want to sell something, you have an idea. So making a forecast whether this will sell or not, that you will learn here. Scheduling you will learn over here. Project management you will learn over here. What kind of model should be followed in a bank, you should learn over here, where customers are coming and we are solving their problems at different counters, you will learn over here. So this is the importance of this subject, industrial engineering. And yes, inventory, very important chapter, forecasting, scheduling, per CPM, queuing, linear programming. All chapters very important, because in this particular subject now you can't say from where the question can come. But if you do not have time, you can ignore. Most important chapters are linear programming, per CPM, and then these fall in the second category. But from the first two, that is double star chapters, 2 questions will definitely come. Guys, what you are going to learn is actually applicable in real life. So if you do preparation, GATE exam is the one exam which will definitely give you the fruits if you have done hard work. Sometimes it happens now that a student prepares for the entire year, but on the GATE exam he or she becomes nervous. So that student was capable of getting 80 marks, but he or she got only 55 or 60 marks because of silly mistakes. GATE exam is one exam that if you get high marks, definitely you will be paid the best. But even if you are getting medium marks, then also you will get something which will develop your career in best possible way. Okay. So please prepare for GATE exam with full dedication, discipline, revise on daily basis, solve as many as practice questions, because this will not only ensure your bright future, but actually it will ensure that these 4 years of your BTech are not getting wasted and you are actually going to be called as engineer after your BTech, because your concepts will be like crystal clear. Even if right now your concepts are not clear, don't worry, start with doing hard work. After 8 months, 9 months, you can say yourself, you will be proud of yourself that yes, I have sufficient amount of knowledge and I can call myself as an engineer. Okay. So all the very best for your exams, and I hope you get what you deserve. Thank you. Bye bye.